Deductive arguments. This is part of argument basics, so it doesn't go into the detail you'd get in a critical thinking or dedicated logic class. Now, a deductive argument is, of course, an argument, so it's going to have one or more premises and a single conclusion. The definitive quality of a deductive argument is this. A deductive argument is an argument in which the premises are intended to provide complete support for the conclusion. And I say intended because a deductive argument can fail. So if you have an argument that succeeds at doing what it's supposed to as a deductive argument, it would be, as we saw before in the previous video, it would be valid. If it fails at this and tries to be valid, then it would be invalid. There are some logic books that consider only valid arguments deductive and classify invalid ones as not, but that gets a bit confusing. But in case you've had a logic class where they make that distinction, this is a point of disagreement among some logicians. So in a deductive argument, the premises are offered as evidence that the conclusion must be true. Not that it's probably true or likely to be true, but that it must be true. And the general kind of stereotype of a deductive argument, the way it's presented is that the conclusion, people typically say, is not supposed to go beyond the premises. So those are some of the key qualities of the deductive argument. Complete support, supposedly, and the premises are offered to show the conclusion must be true, and the conclusion doesn't leap beyond the premises. So how are deductive arguments used philosophically? Also in the paper. Now, deductive arguments are often used as a logical frame to present points established in other, typically inductive arguments. For example, to use an example from aesthetics, some might argue that sexist art is harmful. A person might build an argument using that claim, and the claim that if sexist art is harmful, it should be censored, as premises. So a person could build the argument like this. Premise 1, if sexist art is harmful, it should be censored. Premise 2, the person would say, I've established that sexist art is harmful in my previous, arguments. Therefore, conclusion, sexist art should be censored. And that'd be an example of using a deductive argument as a logical framework. Now, their main use, as you might imagine, is when you would want or need certainty in the logic. Because with a deductive argument, if the premises are all true and it's valid, it gives you a guaranteed true conclusion. So how do you tell when you've got a good, bad, or ugly deductive argument? Well, there are a variety of means of assessment. One is, which is the least effective, is guessing. If you're dealing with a deductive argument and you're just guessing, well, it's either valid or invalid, so guessing has a chance of working. Not really good, though. There's also what's called the analogy method, because any argument with the same form as a valid argument would be valid. To use an analogy to math, the structure of a deductive argument is rather like a mathematical formula. So if you have a correct formula that, like say the Pythagorean theorem, if you put in, the right numbers in the right situation, you always get the right result. And anytime you use that formula, you'll get, it'll be a good formula. Likewise for a valid argument. If it has the same structure as a valid argument, known one, and then you have the same, formal structure, it will be valid, because all arguments that are valid arguments built on that same structure will obviously be valid. Now, this method does require that you know the particular form, and there are quite a few forms of deductive arguments, but there are some that are pretty commonly used. So if you recognize that a particular argument is of a form that's valid, then that particular argument will be valid. Now, there's also an informal method which is not incredibly reliable but possible to use, which is this. To assume the premises are all true, and ask yourself whether the conclusion could still be false. And this method is not completely reliable because people can believe that a conclusion is true for a whole range of reasons, and so this could be, problematic. But it's a way of testing it. So if you don't have the time to work out a better method, you could say, okay, I'll assume all those premises are true. Could that conclusion be false? So, for example, take my usual day of the week argument. Premise 1, if today is Thursday, then tomorrow is Friday. Premise 2, today is Thursday. Conclusion, tomorrow is Friday. And you would ask, could it be true that today is Thursday? And could it be true that Thursday is followed by Friday? And could it be true that tomorrow is not Friday? That is to say, it would be false that tomorrow is Friday. And thinking it through, that seems impossible, so would seem to be deductive, which it is. Now, if you want methods that are guaranteed to work if you use them correctly, there are formal methods, truth tables, proofs, Venn diagrams, and these are definite and objective methods of testing validity. We won't talk about any of those anymore in this course because doing truth tables, proofs, and Venn diagrams is quite involved and the kind of thing you do in a dedicated critical thinking or logic class. Now, we use these tests to decide if a deductive argument is valid or invalid. And those are the only two options for a deductive argument in terms of the quality of logic. There's no degrees, it's strictly binary, valid or invalid. As we saw previously in the previous video, deductive arguments also have the quality of being sound or unsound. The definition of validity is very straightforward, but can be kind of confusing. And this is the definition. A valid argument is such that if all the premises are true, or were true, then the conclusion must be true. It guarantees the truth of the conclusion. Now, it's important to note, as I mentioned before, and I'll emphasize this quite a bit, that valid arguments don't need to have actual true premises, because it's a conditional. And the usual sort of metaphor analogy I use is think about taking a math class or a physics class where you're working with like equations. So imagine like one of those word problems where you're talking about like a train A and train B. You're heading towards city C at particular speeds. When will they reach the city? And of course, this is all made up. There's no train A or B. There's no city C. It's all imaginary for the problem. But you can still do your math correctly or incorrectly. Same with the valid argument. You can put in stuff that's, have stuff in there that's not true, but the reasoning can still be good. So valid doesn't not mean true, it's a conditional. It means if you put in true stuff, you get out a true result. Just like, to use another metaphor or analogy, imagine you're taking like a business class and you're learning how to calculate interest rates. And you're not going to be actually required to take out a loan or loan somebody money to do the math, have to have real money loans to do your calculations. The idea would be the equation would be correct, would be if you put in correct information, you'd get out a correct result. Same with the valid argument. The valid argument says, hi there, I'm valid. Give me true stuff, I give you true stuff back. Give me false stuff, no guarantees. So an argument can be valid and everything in it can be false. The only thing you can't have is a valid argument with all true premises and a false conclusion. And that's by definition. Again, going to the math analogy, if you have a equation that is a correct equation, you can't put in correct numbers and get a wrong answer by definition. You can put in wrong answers and get a wrong answer. That's something that would happen. So validity, again, one way to think of it is think of it like a correct, math formula. Now, what about the invalid? Well, an invalid argument is one such that even if all the premises are true, the conclusion can still be false. Now, invalid doesn't mean false, because you could have an invalid argument in which everything is true. And my usual example, which I've used before, is the Tallahassee argument. Premise 1, if Tallahassee is the capital of Florida, then it's in Florida. Totally true. Premise 2, Tallahassee is in Florida. Also true. Conclusion, Tallahassee is the capital of Florida. Totally true. So in that case, everything there is true and it seems plausible. But it's a bad argument. Why? Well, if it's a valid argument, then whenever you have an argument in the same form, it will still be valid. So let's replace Tallahassee with Sopchoppy. If Sopchoppy is a capital of Florida, then it's in Florida. Premise 2, Sopchoppy is in Florida. Conclusion, it's a capital of Florida. So all the premises are true, but we have a false conclusion, because Sopchoppy is not the capital of Florida. It's Tallahassee. So in that case, kind of the bad logic is more visible, because you can see, okay, we're going from true premises to a false conclusion. But the one about Tallahassee, even though everything was true, was still invalid. Because invalid doesn't mean false. It means, bad logic. That all the premises could be true and the conclusion could be false. So this will sound kind of weird again, you can have an invalid argument, bad logic, in which everything is true. Just like you could have, suppose you're putting together an Excel spreadsheet for a class, and the formula there's a mistake in it. By pure chance, it may give the right answer, even though even though the code is bad. And invalid arguments are like bad programs. Yeah, you may get everything right, but it's not reliable. So what if you have an argument that is actually valid and does in fact have all true premises? Well, then it would be sound. So if you know an argument is sound, you know it's valid, you know it's deductive, you know it's an argument, you know it's got all true premises, you know it's got a conclusion. You know a lot about it. Now, validity is forever. If an argument is valid, it has always been valid and always shall be valid and forever and ever. That's because validity is a structural feature. Now, soundness, though, can change day to day, moment to moment. Going with my Thursday argument, if today is Thursday, tomorrow's Friday, today's Thursday, tomorrow's Friday, that is only sound on Thursdays, because only Thursdays are Thursdays. But it's valid every day of the week. It's always good logic. It's just the case that it's not always Thursday. So valid arguments are always valid, but sound arguments, they may be sound sometimes and not sound at other times, because it rests on the premises being true and being valid. A valid argument is always valid, but arguments, their premises can go from being true to false, like the day of the week example shows, because again, it's only Thursday on Thursday. Now, being unsound can happen in multiple ways. If an argument is invalid, it's unsound. If it has one or more false premises, it's unsound. And of course, it could have both. It could be invalid and have one or more false premises, making it unsound. So, quick recap. Deductive arguments, they are intended to be such that the premises guarantee the truth of the conclusion. That is to say, they're supposed to be valid. Invalid means if all the premises were true, the conclusion must be true. Invalid means you could have all true premises, but could still, because of the bad logic, have a false conclusion. Sound is valid plus all true premises, and you get a true conclusion kind of for free. And unsound can happen three ways: invalid, or one or more false premises, or both. Now, what about some forms of arguments? Well, there are some very common deductive arguments, and they're so common they get particular names. Now, in theory, there are an infinite number of valid arguments and invalid arguments, so they obviously don't all get names. But here are four that are so common, they've gotten names. The first one is modus ponens. It's a valid argument. It's also sometimes known as affirming the antecedent, because in the first premise, if P then Q, P is the antecedent and Q is the consequent. And those are just for the position they're in. To use a sports analogy, if you're standing on the mound in baseball and you're supposed to be there, you're the pitcher, because that's where you are. If you're behind the plate in baseball and you're supposed to be there, then you're the catcher. And so they're basically just the position. So in the if P then Q, the thing behind the if is always the antecedent, and the thing after the then is always the consequent. So modus ponens would have the following structure. Premise 1, if P then Q. Premise 2, P. Conclusion Q. And these P, Q, and Q's are variables. Just like in math, you could put anything you want in there. For example, like my day of the week argument, you could have if today is Thursday, then tomorrow is Friday. Premise 2, today is Thursday. Conclusion, tomorrow is Friday. Or you could have something more elaborate like if killing in war is like murder, then it is immoral. Premise 2, killing in war is like murder. Conclusion, it is immoral. The next argument is the modus tollens, the mode of denial, whereas modus ponens is the mode of affirming. Modus tollens is known as denying the consequent, because, as we'll see, the consequent is denied. Premise 1, if P then Q. Premise 2, not Q. Conclusion, not P. So, for example, premise 1, if reality is just a dream, it should seem fairly incoherent. Premise 2, reality does not seem fairly incoherent. Conclusion, reality is not just a dream. A third one is the hypothetical syllogism, also sometimes known as a chain argument, and it's valid. If P then Q is premise 1, premise 2 is if Q then R, conclusion, if P then R. For example, if cheating is wrong, then cheating in class is wrong. Premise 2, if cheating in class is wrong, cheating on this test is wrong. Conclusion, if cheating is wrong, then cheating on this test is wrong. The disjunctive syllogism, also a valid one. Premise 1, P or Q. Premise 2, not P. Conclusion, Q. For example, premise 1, Bill can lose weight through surgery or diet and exercise. Premise 2, Bill decided not to diet or exercise. Conclusion, Bill has decided to lose weight through surgery. Now, there are many other, as I said, there's potentially an infinite number of deductive arguments, dilemmas, etc. Some have names, many do not. Since this is not a dedicated class in logic, I won't go over those. These are mainly here to sort of illustrate some of the standard forms. And in terms of the paper, a good question would be, do I have to use these, any or all of them, in my paper? And the answer is no. The odds are you won't use any deduction in the paper. One of the main reasons why we're covering deductive arguments is because, one, if you take a philosophy class, you should learn about deductive logic. Secondly, some of the philosophers we'll look at do use or attempt to use deductive logic as a method, and so we'll need some background for that. And there's a chance you, very slim, you might use in your paper. We now turn to the last bit of deduction, and we'll see more of this in the future, but it's a pretty useful method in philosophy and outside of philosophy. It is the Reductio Ad Absurdum. Now, there's two forms of this. The kind of the standard one is, it's when you prove that a claim is false by drawing an absurdity from the assumption that it's true. Or you can reverse this. You can prove that something is true by assuming it's false and deriving an absurdity. So it's, the translation would of course be reducing to absurdity, and the idea is you assume something, get an absurdity, and then reject the assumption. So form one is this. You assume that a claim is true in order to disprove it. You prove that P leads to an absurdity, a contradiction, etc. And then you conclude, therefore, it's false. And the way to do this deductively is to show that the assumption of P leads to a contradiction. And of course, contradictions are, they can't be true by definition, they're always false. And so you conclude that the claim P is false. The second form is to assume that a claim is false, and this is to prove that it's true. And you prove that assuming not P, that it's false, leads to an absurdity, ideally a contradiction. And if assuming, not P leads to a contradiction, then P must be true. For example, suppose someone is having a debate over the definition of oppression, and someone advances a not implausible definition, that oppression is defined as the mistreatment of a numerical minority by a numerical majority. So how would one reduce that to absurdity? Well, this can be done pretty easily. In the case of sexism, there is actually a majority being mistreated by a numerical minority, typically. Because although more males are born than females, not like a huge amount, but there are more males than females percentage-wise, there are more women than men, ultimately. If you've seen movies like Jackass, Jackass 3D, etc., things involving shopping carts and rockets, that kind of explains in part why there are fewer men. Not a huge difference, but it ends up being numerically a minority. Therefore, since women are a numerical majority, sexism is not oppression. And that, of course, is absurd. So the definition is flawed. And we'll see in the future other examples of the Reductio Ad Absurdum. It was a favorite of our good dead friend Socrates, and is still useful. It's an effective means of trying to show that something is true or false. So that brings us to the end of our discussion of deduction. And again, you're not required to use any of these in the paper, and this is kind of a shallow dive into deduction because a proper coverage could take an entire semester. There are entire courses dedicated just to deductive logic. So stay safe, and I'll see you in the future.